Hello everybody and welcome back to Unit 7 of Regents Chemistry, where we'll be talking about chemical bonding. Today we will be talking about the last topic in this unit, which is how to name compounds, both ionic and covalent. So there's this organization that basically names all of the chemical compounds. It's called IUPAC, which is International Union of Pure and Applied Chemistry. So a lot of times in Regents, you'll notice that the question will say, write the IUPAC name for this thing, and you'll be given a formula and you'll have to write the name of that thing. So basically, do not get worried because all that the question is asking for is just name it. So there are some things that are super important to take care of when you're naming compounds. And the first one and the most important one is that before you actually name the compound, you must identify that compound. You have to tell whether it's an ionic compound or a covalent compound because that's the first step. And then remember, all compounds are electrically neutral, which means their charges should be equal to 0. If they're not equal to 0, then we use the crisscross method to make sure that their charges do equal 0. And finally, remember that whenever we have an ionic compound, the positive ion is always written before the negative ion. So we have the positive ion followed by the negative ion. So let's begin by learning how to name ionic compounds. And there are two ways in which we kind of classify the ionic compounds based on how we name them. So the first type includes all of the ionic compounds where we have the metals that only have one oxidation state or one oxidation number. So the first thing that you do is when you're given a compound, you observe the positive part of the formula and then you locate that element in the periodic table. Now, as you go to the periodic table, you look for the oxidation numbers or oxidation states for that element. And I'm going to show you guys in just a second where do you find those. If it only has one, then that should tell you that this belongs to the type 1 ionic compounds. So you just name the positive portion, whatever the name of that element is, and then you name the negative portion or of the thing, the negative element, and whatever is the name of that element, you end that with an "ite." Okay, so take the root of the name of that element and then end that with an "ite." So here's an example. Let's say we are looking at NaCl. So you look at the positive part, and this should be a no-brainer because remember we just said that the positive part is always the first one and the negative part is always the second one. So we know that Na is the positive portion. So here we have Na, then we have Cl, which is negative. So you go to periodic table and you find Na, which is sodium, right there. Now, the oxidation numbers are given in your periodic table in the top right-hand corner. So right there, we have the oxidation numbers for sodium. Now, notice how there's only one number there. For some elements, there are more than one numbers, so they do not belong to type 1. So only the elements that have one oxidation number belong to type 1. Okay, so now that we know it has one oxidation number, belongs to type 1, we'll just go ahead and write the name of that element, sodium. And then we'll name the negative part, which is chlorine. Now, chlorine, the root for that name would be chlor, and then we end that with an "ite." So the name for this formula basically becomes sodium chloride. Now, sometimes for the type 1 elements, you can also get, rather than just getting a metal and a non-metal, you can also get polyatomic ions, which are basically the charged species that have more than one atoms that are covalently bonded to each other, which means they're sharing their electrons. And there you guys do have a whole bunch of polyatomic ions given in table E, which looks like this in your reference table packet. Now, whenever you are given a polyatomic ion, you guys do not need to do anything with the name. Just use the name, whatever name is given to you in the table, just use the same name. Even if you guys notice, most of them have a negative charge, which means they come second in your formula. So do not add the "ide" at the end if it's already not a part of the name of the polyatomic ion. So for example, cyanide, which is Cn negative, if that is a part of your formula, you'll name it cyanide. However, if we are looking at acetate or hydrogen carbonate or chlorite or hypochlorite or chlorate or any of those, all of them have negative charges, then you just name them exactly the way they are named in this table. Please do not add an "ide" at the end. Okay, so as I said, remember the rules. If you have to name the type 1 elements based on polyatomic ions, you just name the cations. Even if it's a polyatomic ion, you name it if it's a polyatomic ion, just name it as it's named in the table. You do not need to check the oxidation numbers because all of the polyatomic ions given to you in table E only have one oxidation state or one oxidation number. So they definitely belong to type 1. And if they are given as anions, then they are named second. If they are given as cations, they are named first. So just take care of that. So here are a couple different variations that we can see in the compounds of type 1 molecules that could affect how we name them. So basically, we can have a type 1 compound that has a metal and a metal. For example, this one, NaF. So here we have sodium, which is a metal, and then fluorine, which is a non-metal. So you do the same thing for sodium. You go to your periodic table, you locate sodium, you look at the oxidation number. It only has one oxidation number, so that tells you that this belongs to type 1. So you just come here and name sodium just like it's named. And then you have the negative portion, which is fluorine. The root for that would be fluor, and then you end that with an ite. So that would be the name of the element would be sodium fluoride. We can also have a metal and a polyatomic anion. For example, this one right here. So here we have sodium, which is a metal, and then we have OH, which is hydroxide, a polyatomic anion. So in that case, and both of them are bonded together in an ionic compound. So in that case, once again, you do the same thing. You go to your periodic table to find sodium. You look for the oxidation number. You make sure that it only has one, so it belongs to type 1, name sodium. And then because hydroxide is a polyatomic anion, that's how it's named in table E. So there we have table E as a hydroxide, so we just name it as a hydroxide. We don't do anything to it. Next up, we can also have a polyatomic cation and a nonmetal. For example, this one. So here NH4 is a polyatomic anion and fluorine is a nonmetal. So you go ahead and locate NH4 in your table E. That's ammonium. So you just come here and write ammonium like that. You do not need to check the oxidation number because, as I said, all of the polyatomic ions given to you only have one oxidation state. They're only given in like one oxidation form. And then we have fluorine. Now, because it's a nonmetal, the root for fluorine would be fluor, and then we end that with an ide, so that would be ammonium fluoride. Finally, we can also have a polyatomic cation and a polyatomic anion. For example, something that looks like this, NH4, which is ammonium, and then OH, which is hydroxide. So all we have to do is just copy down their names from table E. So that would be ammonium hydroxide. Now let's talk about the type 2 ionic compounds. These are the ones that have more than one oxidation numbers, which are basically some of the transition elements on the periodic table. So in order to name them, first of all, we must tell which of those oxidation numbers is it using. And we have to figure that out using the anti-crisscross method, and which we'll go over in just a second. And then once we know which charge is it using or which oxidation number is it using, we have to report that in the name as well using the Stoch method. So let's see what the Stoch method looks like. So the rules for the Stoch system are, first of all, you definitely look at the positive part and you go and find that in the periodic table, look for the oxidation numbers. If it has more than one oxidation numbers, it belongs to type 2. Now you have to figure out which out of those oxidation states is it using right now. And you can do that by using its formula and doing the anti-crisscross method. So the anti-crisscross method is basically the opposite of the crisscross method that we were doing. So in the crisscross method, we were basically bringing the numbers with the charges down. In this case, we start with the formula and we bring those numbers back up, and that gives us the charge. Okay, so we'll see in just a second what that means. And then whichever oxidation state it is using, when we name the compound, we have to report that oxidation state in a Roman numeral, and then we basically just name the negative portion ending with an I, just like we were doing before. So for example, look at CuCl. Now we look at Cu first, which is a metal, and then Cl, which is a non-metal. So both of them have ionic bonding going on. So we locate Cu in the periodic table, but first of all, we have to definitely do the anti-crisscross method. So here's what that looks like. Both of them right now have a 1 at the bottom because they don't really have any other numbers, so that means there's just that 1 present. So when we do the anti-crisscross method, we bring those ones up, and when we do that, Cu now gets a charge of +1 because we just brought that 1 up, and then Cl now got a charge of -1 because we brought the other 1 up. Okay, so now when we look for copper in the periodic table, notice how copper has an oxidation state of +1 and +2. Well, we just figured out using the anti-crisscross method that copper is actually using the +1 oxidation state. So now when we name it, we are going to write the name of copper, and then in the bracket as a Roman numeral, we are going to write 1, which is basically an uppercase I. That's how Roman numerals work. So and what does that tell us? That we are using the oxidation state of carbon, which is 1. We are using the +1 oxidation state. If let's say we were using the +2 oxidation state, we would have written 2 I's or 2 lines representing that we are, because that's how we write 2 in Roman numerals, representing that we are using the oxidation state of carbon, which is +2. And then finally, we finish it off by naming the negative ion, which is chlorine. So the root for that would be chlor, and we end that with an ide. So that would be copper chloride overall. And then that 1 is representing which oxidation state are we using. So there are only 2 possible variations for the type 2 compounds. The first one is we can have a metal which definitely has multiple oxidation states because this is type 2, and a non-metal. So here we have COCl3. We look for CO in the periodic table and we figure out that, oops, CO has more than 1 oxidation state, so that means it belongs to type 2. So now we have to figure out which one is it using exactly. So we do the anti-crisscross. So this is what the formula looks like right now, COCl3. So CO has a charge of 1, Cl3 has a subscript of 1, and then ClCl3 has a subscript of 3. We bring both of them up to the opposite side to figure out what their charges are right now. So for CO, when we bring that 3 up, CO gets a charge of 3 positive, and then Cl gets a charge of -1 when we bring that 1 up. So now we know that cobalt is using its oxidation state of 3 positive. So now when we name that, we'll say cobalt, and then in the bracket we'll say 3 in Roman numerals, and then we'll name chlorine by ending that with an ide. So the name for this compound will be cobalt 3 in the brackets in Roman numerals, chloride. Another variation that we can have is we can have the metal with multiple oxidation state bonded with a polyatomic anion. So for example, this. Now for this one, we do the same thing. When we look at iron in the periodic table and we figure out that, iron has more than 1 oxidation states, we know that it belongs to type 2. So now we do the anti-crisscross method. So for iron, which currently has a subscript of 1, and then NO3, which has a subscript of 3, we bring the charges up in an anti-crisscross. So iron gets a charge of 3 positive, and then NO3 gets a charge of -1. So which oxidation state is iron using right now? Well, the oxidation state of 3 positive. So when we name this, we'll say iron in Roman numeral 3 because that's the oxidation state it's using. And then we'll name NO3, which is a polyatomic anion. So all you have to do is go to the periodic table, find anion, and the name for NO3 negative is nitrate. So that's what you put in the when you're naming the compound. Finally, let's see how we can name the covalent compounds. And we classify them as type 3 compounds or type 3 binary compounds as we are naming them. So basically, the first thing that we do is we look at the first element in the compound and we name it as it is, using its real full name. And then we look at the second element that we have in the compound and we name that ending with an "ide." Okay, so drop the ending part, just use the root and end up with an "ide." And then we also use the prefixes to show how many of each element do we have. So for example, so these are the prefixes that we use. So if let's say you're only using one carbon, it would be monocarbon. All right. If you're using two carbons, it would be dicarbon. If you're using three carbons, it would be tricarbon. How do we figure out how many carbons are we using? By looking at the subscript. So if there's a subscript of 1, 2, or 3, that basically tells you how many atoms of that element are we using. So the thing to consider or remember actually, when we are naming the first element, we use all of the prefixes except mono. We can never ever use the prefix mono with the first element. But for the second element, we can use all of the prefixes. So we always use it. But let's say we have a compound that starts with one carbon. So we won't say monocarbon di oxide. It will just be carbon dioxide. Okay, so there we go. There we actually have some examples, and the first one is CO2. So we start with the C, which is a carbon. So we just go ahead and name that as a carbon. So carbon has a prefix of 1, a subscript of 1, which means we only have one atom of carbon there. So we are not going to say monocarbon. We'll just say carbon. And then for oxygen, we have two of them. So oxygen, first of all, is going to become an oxide because we need to end that with an "ide." And then because we have two oxygens, we remember our prefixes, and the prefix for two is di. So that's how it becomes dioxide. Here's another example. We have CCl4. So once again, we only have one carbon, so it's just going to be carbon. And then we have Cl4, which means we have four chlorines. The prefix for 4 is tetra. And then chlorine is going to become chloride. So that's going to be tetrachloride. And then we have N2O. So N2 is basically we have two atoms of nitrogen. So remember it's the first element, so I do not want to change the ending for nitrogen. We want to keep it nitrogen, but we also want to add the prefix this time because now we have two of nitrogens, not only one. We can only not use the mono, all of the other prefixes we can use for the first element. So that would be dinitrogen. And then we only have one oxygen at the end, so that would be monoxide because oxygen becomes oxide, and then we only have one of that, so the prefix will be mono. Alrighty guys, so just a quick review for all of the things that we need to take care of when we are naming compounds. First thing that we want to identify is if it's ionic or covalent. If it's ionic, then look at the oxidation state of the cation or of the metal. If it only has one oxidation number, then it's a type 1. If it has more than one oxidation numbers, then it is type 2. Then follow the rules for whichever type it belongs to. And then remember, if it belongs to type 2, you have to figure out which oxidation state is used by doing the anti-crisscross method. And then if it's covalent, then it will be type 3. Follow the rules for that. Make sure to use the prefixes. So here's a pretty detailed breakdown of that. So first of all, you look at the type of compound. It could be either ionic or covalent. If it's ionic, it could be type 1 or type 2. If it's covalent, it could be type 3. So for type 1, remember that it only has one oxidation state, so that means no Roman numerals. We do not need to write the Roman numerals. Different variations that we can have is if it's a metal and a non-metal, then we write the positive atom, negative atom followed by an ite. If it's a metal and a polyatomic anion, then just write the positive atom and the polyatomic anion. If it's a polyatomic cation and a negative atom, a non-metal, then you write the positive polyatomic cation and the negative atom ending with an ite. Finally, if it's a polyatomic cation or polyatomic anion, stays the same as it's found on the periodic on table E. So polyatomic ions, you always just copy the names from table E. Do not mess up with their names. Just copy them down from table E. For type 2, they have multiple oxidation states. That means you need to identify which one is the compound actually using and then write that in the Roman numerals. Two different variations that it can have is it can either have the positive atom uh, uh, with, a metal and a non-metal. So you write the positive atom, the oxidation state used in Roman numerals in the bracket, followed by the negative atom ending with an ite. Or it can just have the positive atom or the metal with a polyatomic anion. So you do the same thing with a positive atom, writing the oxidation state in the brackets and the polyatomic anion, which will be the same as it is on table E. And remember, no polyatomic cations have more than one oxidation state, so there's no way you can ever have a type 2 compound that has a polyatomic cation. Finally, for the covalent or for the type 3 elements or compounds, you just use the prefix except mono and the name of the first element, followed by the prefix again and the name of the second element ending with an ite. Alrighty? And finally, there you go, beautiful people. We are done with this chapter. So I'm going to peace out with that. Take care. I'll see you guys in the next one.